Hi everyone, I'm Chen Wang from Department of Mechanical Engineering at Northwestern University. And today I'm happy to be here talking about my research on solar cell design. With the ever faster development of this world, environmental pollutions become more and more serious due to the emission from larger energy consumption and industrial production. This problem is especially prominent in developing countries like China. Beijing, the capital of China, attracts people's attention in recent years due to its deteriorating air quality. Forbidden City, which is the world-famous historical palace, is covered by this heavy smoke during the polluted days. And people have to isolate themselves from this city, which is really sad. So if we can reduce the energy consumption, such as burning less fossil fuel, then we may reduce the hazardous air released to the atmosphere. So one of the solutions is solar cell. So what happened in a solar cell is sunlight can excite electron and hole pair in active layer of the solar cell. And when they get separated and transported, electricity can be generated. So basically, solar cell can transform sunlight into electricity without any emission. So nowadays, you can see solar panels. You may see them mounted on the roof of the house to provide the electricity for the household usage. You may see this large solar array in the desert in the western part of this country and form huge solar power plant. And you may see this fancy solar car running on the Sheridan roads. I think there is a team at Northwestern building this kind of car. However, solar cell is still not the dominating technology for the electricity generation. So the main reason is the price is still high. So people believe the promising future is thin film solar cells. The basic idea of it is to use less materials, and then you can lower the price. Moreover, thin film solar cells have other exotic functionalities, such as it can be deployable for military use, it can be semi-transparent, so you can mount it on your window and it won't blocking the incoming light. And it can also be flexible, so you can fold it and put it in a truck and take it for a picnic. However, even though the price is lower because it uses less materials, then the efficiency will be lower. So the question is, how can you maintain the efficiency? So there is a technology called light trapping technology, which was proposed in the 1980s. So the basic idea of it is to texture the front surface of the solar cell. And then the surface will scatter the incoming light into different directions. Due to the total internal reflection, light will be trapped inside of the active layer. Hence, it will have higher probability to be absorbed. So basically, by incorporating this light trapping technology into a solar cell, we can achieve higher efficiency with less materials. However, this random texture is not optimal for the light trapping. Texture needs to be properly designed in order to generate maximum electricity or efficiency. So this is where my research focusing on. Try to design and optimize the texture for the light trapping. So then the question is, how can you design it effectively? So let's focus our attention on biology a little bit. So there is a theory called natural evolution theory, which was proposed by Darwin. So in this theory, they basically say that human beings evolve to be stronger and more intelligent. So if somehow we can mimic this natural evolution process and evolve our solar cell to be more efficient, then that sounds like a good idea. This is what exactly we're doing in my research. So we start with a bunch of designs, and then first of all, we'll go through selection process, after which designs with better performance will be selected. This actually reflects the essence of natural evolution, survival of the fittest. And after that, they will get in pairs. Each pair will have two offsprings. Just like one family have 2 children. After that, they will go through the third step, which is called mutation. So they will have a certain probability to be mutated. So these 3 steps actually are mimicking the natural evolution. So by using this algorithm, we can optimize this pattern and get this optimal design. And also we can experimentally realize this pattern by using advanced nanotechnology fabrication techniques. So by using this algorithm, we can evolve the solar cell to be more efficient. And this is a collaboration project done by Professor Chen and Chen in mechanical engineering. So this is a 3D view of this solar cell we optimized. We can see by construct this scattering layer on the top, light will be scattered and trapped inside this very thin active layer. And the optimized structure actually have 10 times higher absorption than the planar reference. So in conclusion, for solar cells, price is still high. And thin film solar cells are price competitive, but have to be properly designed. So in my research, we use this natural inspired algorithm to design and evolve this solar cell to be more efficient. So hopefully we can get rid of this ghostly dust and restore the beauty of the city. Thank you.